Hello and welcome. This is the PendulumRoller balancing robot. As the name suggests, it is a robot which uses a pendulum to balance over a cart with a pair of free rotating wheels. The robot has three main parts: the base and wheels assembly, the pendulum, and the servo box assembly, connected by a pair of vertical struts. The fourth component, the lifter assembly, rotates to move the robot back to a vertical, controllable position after a fall. All of the electronic components and the battery which powers the robot are contained inside the pendulum, reducing the wiring challenges and serving as pendulum ballast.
The servo box contains several components. The first component is the rack and pinion that is part of the decoupler mechanism. The point of the decoupler mechanism is so that we can engage and disengage the main pendulum when the entire robot falls, so that when it does abruptly fall, we don't accidentally damage the main motor, because the main motor is going to be driving the pendulum, which obviously has a lot of weight. And then that pendulum is obviously connected to the main motor, which does the main PID control. The rack is designed so that even though we only have one slot keeping it up, it resists moments by having a cross-braced support that lies against the top.
The pendulum has a teardrop design to provide a large moment of inertia around the rotation axis and to gently guide the pendulum into a resting position after a fall. The star-shaped cutout engages with the horn on the main servo motor to provide control and to balance the assembly. The battery fits into a slot on one side of the pendulum, and the ESP32 and Raspberry Pi are attached in a compartment on the other side.
The wheel design was inspired by Alfa Romeo, and it also has a rounded edge design so that when it falls, there is sort of a guided path for the robot to fall along, so that it isn't just a jagged fall onto the floor.
The lifter arm is there to help the robot lift itself up from falling over 90 degrees either way. Currently it doesn't quite have enough strength, but we believe with more time and an extra motor it would be able to. For the sensors, our ESP32 is handling all of the control and calculations, takes all the data from the sensors and gives it to the motor driver. So for our control loop, we are using a PID controller, and we're feeding it the error of what our angle from the IMU is telling us versus our target angle of 0 degrees, aka vertical.